Hello, this is Yassine Ali. This is Yassine Ali Bouzair. I'm a petroleum engineering student, TP047629. So here is the project code. Starting with the introduction of my topic. So my topic is about oil and gas, is about increasing the production of hydrocarbon, which is oil and gas. So what's hydrocarbon? Hydrocarbon is an organic compound that is composed of carbon as well as hydrogen atoms. It is an important source of fuel and energy for crude oil, coal, and natural gas. So a lot of technologies have been developed to extract these resources from deep, very deep underground. One of these technologies is called EOR, Enhanced Oil Recovery. So now we go to the meaning of enhanced oil recovery. Enhanced oil recovery is a technology that has been discovered in order to increase the production of oil and gas, as there is some oil and gas or some petroleum or some hydrocarbon that is trapped deep underground that is not easy to extract them. Now we have different types of EOR. We have primary recovery that is dependent on natural pressure depletion, as well as evaluation of dissolved gas that are generated naturally by natural energy. This is primary recovery. Now we have secondary recovery that takes over after that natural drive, which is primary recovery, has declined. So the energy like solvent, chemical, or thermal must be added to the reservoir in order to allow more oil to be recovered or more oil to be produced. In the earliest of 1940s, water flooding became the proper method for secondary recovery. So water flooding, we're talking about injection of water in order to produce oil, to sweep the oil, as we can see on the picture, to the production well. So oil recovery is about 12 to 15% for primary recovery. Now we have the tertiary recovery. Tertiary recovery is processed after secondary recovery in order to displace the enrichable oil or trapped oil or residual oil by thermal means, chemical injection, or by changing oil-water mobility ratio. So the chemical injections here, we're talking about different type of chemicals. One of them is called surfactants. So surfactant has been used in the industries for a very long time and has been discovered for a very long time. So what is surfactants? Surfactants are surface active agents, are organic compounds with double parts, which are hydrophobic tail and hydrophilic head. Surfactants are classified into different types. We have anionic, non-anionic, zwitterionic, and cationic. Every one of them has different charge. So now we go to the purpose of injecting of chemicals such as surfactant. The purpose is to reduce the interfacial tension, which is called IFT. So we have trapped oil or residual oil that is hard to reach, or it's unreachable. It's hard to sweep it. It doesn't sweep naturally. So when you inject this surfactant, you're going to allow the trapped oil to be produced. As you can see on the picture on the left side. So here, before surfactant flooding, oil is trapped between the rock surface, and then after injecting the surfactant, the IFT is used, which produces the trapped oil to be produced. So that's the purpose. It's producing more oil, and reaching the enrichable oil or residual oil. So now the idea is, after studying the surfactant and if there is any issue that the industries has been facing, I found out that the surfactants are very expensive. So so are very, very expensive. So therefore, we need another type of chemicals or another idea or innovative solution that can, be more economical and give us, of course, maybe probably more IFT reduction, which means more oil produced. Therefore, I've studied and analyzed the nano surfactant, which is surfactant but in nano size. So, first of all, it's more economical, obviously, because it's nano sized. Nanotechnology significantly improves the fluid flow back after fracturing operation. Nanosurfactant absorption on the hydraulic fracture face area. This enables nanosurfactant to flow deeper and enhance its flow back by decreasing the interfacial tension, which is the purpose or the goal of the industry. Nanosurfactant shows the lowest contact angle, as we can see on the picture. The oil was having the high contact angle, and then by injecting surfactant with nanoparticles, which is called nanosurfactant, this indicates a low contact angle or more ability to water wet surface. So before it was oil wet, which is oil trapped between the surface. Now we have water wet. That's what we want. It maximizes oil relative permeability. This nanosurfactant help to reduce interfacial tension to less than 10 mn per minute between oil and water, led to the releasing residual oils remain inside pores. So injecting nanosurfactant leads to release of residual oil and sweep the oil to the production well in order to be produced. Here the small experiment methodology that I have created or I've come up with. So using the attention sigma 702, this is an equipment to test the IFT. So in my studies, I prepared nanosurfactant, different concentrations in order to find which type of surfactant and which concentration that can give me more IFT reduction or interfacial tension reduction, which means produce of oil or sweeping of oil, displacement of oil. So first of all, we prepare different nanosurfactant, different concentration. We mix surfactant with distilled water to form solution. Then we wait to be stabilized, and then we transfer it to the attention sigma 702. Then we pour oil on the top of the solution. Then we wait until the separation happens between the oil and solution. So the interfacial tension is ready now to be tested. We test the IFT, and then record the interfacial tension result, the data, and then we repeat the experiment on different nanosurfactant and different concentration. So now at the end of the experiment, we will be having the data, the results, and then now we compare which nanosurfactant give us the better IFT tension and at which concentration. There's different concentration, 10% weight percentage. There's a lot of concentration that to be considered. So that's the experiment is about. And thank you so much. I appreciate it. Thank you.